ELI5 is the fabric of space, bendable but also not visible by eye. If you travel to a place where a solar eclipse will occur while the sun is transiting some bright stars and avoid clouds in World War I and photograph the eclipse sun through a telescope in front of the stars and then wait 3 to 6 months depending on the local time during the eclipse to take photographs of the stars again, you get this, from this paper. The effect is detectable but tiny here in the solar system. I think what happens is that our brains want us to see things as we expect them to be, flat and static in the way we assume the universe operates. It's like natives of New Guinea calling airplanes birds. The mind turns one thing into another in order to understand it. So we do see curved space, but we understand it only by seeing it the way we already understand things. A planet moving back and forth must actually be moving forward, then backward, which of course cannot happen. But there it is up there right in front of our eyes. Magnetic fields are invisible, too, but they can also be bent. One way to demonstrate that is by holding a compass close to an electrical circuit carrying charge. The needle of the compass will stop pointing north and realign with the wire so long as the power is turned on. It's important to remember that when we talk about fields, bonds, and the fabric of spacetime, those words don't refer to material objects. They are analogies that describe how objects interact with each other. The thing is, it bends on the fourth dimension so we can't perceive it. You'll see the bending on fabric because you understand tridimensionality, but a 2D being wouldn't be able to see it because it occurs outside of the dimensions he can perceive. You would need to take him out of his 2D plane so he can observe how it stretches on the z-axis, but from his POV in 2D it looks the same, only from the outside would you see the difference. You do see it. You don't see the orbital path of a planet because it's not surrounded by yellow and white highway lines, but you do see the planets move in a circle. If you want to see a space curvature painted with visible colors, look for pictures of a black hole or a gravitational lens. It's an analogy. The easiest way for us to understand how space works is to compare it to a fabric. It may be very reductive, but the core idea is that space is kind of a fabric that's not a singular plane, but an infinite sphere made of an infinite number of such fabrics, and the effects of gravity are, as a result, visible on any plane in space. I'm sorry if this made it worse. Find a star in the sky, but make sure when the sun comes around that it comes in front of it blocking your view. Then wait for a total solar eclipse, go to totality where the sky will be completely dark. Now the star that would have been blocked by the sun's presence, and not just its light since it's dark, that star might be visible. Its light will visibly curve around the sun. It also doesn't help, our understanding could be wrong. The idea of curving spacetime isn't compatible with quantized gravity. Until we further understand what's going on, GR in its current form is the best we can do. Both theory and experiment have stalled. Because it doesn't bend very much nearby us, we need to look a long way away. Then we see it in many places. But you need a telescope to see that far. The obvious one is seeing the ring lines that show space is working as a giant magnifying glass. You see this galaxy behind this here massive star? Notice how its light is warped around the star? That's seeing the fabric of space and time warped in the light bending around the deviation. You can't see space-time. What you see is its effect on other objects. Think of wind. You can't see the actual wind, but you can see leaves and trees being blown by it, and you can feel it. You can see it in extreme cases, or, at least its effect, like light bending around a black hole or gravitational lensing around a cluster of galaxies. It can be visible. There are effects called Einstein rings and gravitational lensing which demonstrate the curving of space. The best video you will ever see on the visualization of space-time and general relativity. The channel is awesome. Blankets reflect light which hinders your eye and is absorbed by your retina. Space can transmit light, but doesn't reflect it. I'll just add that you don't see air, but we can see what it's doing to things as wind blows. Seeing gravity is like that. Take entheogen. You'll see the fabric of space-time bending. LSD or the right mushroom will do the trick. Space itself is invisible though, so it's not like a bent space would be any more visible than a flat one.